linear algebra is used. So today's lecture is particularly planned to have idea about applications of linear algebra. With these words, I invite our speaker, Professor Gaurav Sharma sir, to please start his talk. Gaurav sir, please start.
Yes, thank you, sir. Uh, Thank you so much for giving me this opportunity to share my ideas with all the students. We had a wonderful program from last 2 weeks. I think all these resource persons are really enjoying talking and discussing concepts and geometry and all things with the students, and it was really very interactive with all of you, and we really enjoyed talking to you all. So next, this is our last session. And it is a very important session, that is the application part of linear algebra. As Sangeet sir has already shared his view that mathematics is a subject in which we generally don't link our concepts and our theory with the application part. So here is a small effort to connect the whole concept, the whole ideas that we discussed in these days with the day-to-day life we are using. Knowingly or unknowingly, we are using linear algebra. So today we will discuss how we are using this linear algebra in our daily life, right? So let us start. I hope you will really enjoy. This is just a PPT part. So let us discuss these one by one. Application of linear algebra. We have covered these topics, and topics are vector spaces, linear combination, linear dependence and independence, basis and dimension, linear transformation and matrix representation, eigenvalues and eigenvectors. So I will be focused on the application part of these topics only. In fact, I am not covering all the applications. There are so many applications regarding to each of this topic, but I will touch only few that you can connect with yourself, which you are using in your daily life. So I am just touching that part of application only. I will not touch the core concepts of physics, chemistry, but I will touch only the application part that you use in your daily life. Okay, so let us start with the first application, the application of linear combination. So this is the RGB. Yes, do you know what is RGB? It is the combination of red, green, blue. So color on the computer monitors are commonly based on what is called RGB color model. So colors in these systems are created by adding together the percentage of primary colors like red, green, and blue. And one way to do this is to identify the primary colors with the vectors. Now see, in RGB, every other color except red, green, and blue, we can mix this color and we can find the any other color by the combination of these colors. So whenever we talk about the combination, then immediate thing that comes to our mind is linear combination. So in general, if we want to apply this RGB in a mathematical form, then we take pure red as a coordinate 100, pure green color as a coordinate 010, and pure blue color as a coordinate 001. Now it is just a standard basis. As you can see, I have taken red along x-axis, green along y-axis, and blue along z-axis in R cube, in space coordinates. Now see how it works. To create all other colors by forming linear combination of R, G, and B using coefficients between 0 and 1. These coefficients represent the percentage of each pure color in the mix, right? So one thing is noticed here is that what will be our black color and what will be our white color. So white color don't need any combination. It doesn't need any mixing of any color. So if we, first of all, we will give coordinates to these two colors. That is black. For black, we have given 0, 0, 0. If it is a 0, 0, 0 coordinate, then it is a black color. And for 1, it is 1, 1, 1. Right? So all other color will lie in this cube, because we are talking in 3-dimensional space. So the diagonal from black to white will represent the shades of gray and so on. Now see how. This is the picture. So this diagonal color is the gray color. Gray, it is moving a blackish gray to a whitish gray up to 1, 1 point. This one. So here is a black, here is a blue, here is red, and here is green. You can see this is yellow, 1, 1, 0. It is the combination of green and red. So we'll get yellow. And sign, if we take the combination of blue and green, and all the colors of all the existing colors will lie in this cube. Now you can see there are infinite number of combinations, right? So if we want any color, suppose we want magenta, then we need to just to put the percentage of the colors, which colors will involve here, and if we add those colors in a correct percentage, we will get the required result. You see magenta is here, 101. We don't need green in magenta, right? So this is how it works. Now where this RGB is used, now see the very first example of RGB, application of RGB is a digital display in like the monitor I am using. It is also using the same concept of RGB. The various colors on this monitor are just the combination of these 3 colors in a correct way, so that I can view that particular color in a 1 pixel. Now 1 pixel is a small part of the screen. So that pixel, the combination of all pixel, that changes the, that gives the a full screen, right? So here LED displays such as television, computer monitor, and large screens use this way of display. So each pixel on these displays is built by using 3 small and very close RGB light source. At a common viewing distance, these colors cannot be distinguished. Now I cannot distinguish the pixel, where are the small pixel area, but when I see as a whole, it gives me the exact picture, right? So it is just based on RGB. A 1 pixel decides the combination of these 3 colors, and when we combine all pixels, we get exact picture. The second application is a scanner. Again, an image scanner is a device that scans physical documents or converts it to a digital form and transfer to the computer. So how the scanner works? How it takes the how it scans the image, a colored image. So it uses that concept of RGB only. So there are different types of such scanners, and most of them work based on RGB color model. These scanners use a charge coupled device that, or a contact image sensor as the image sensor. Color scanners often read data as RGB values. So it only reads data as RGB values. These data are then processed with some algorithm to convert to other colors. So here where RGB is used in a scanners. So other application is RGB in formation of paint colors. Whenever you visit any shop of a paint, then there you will see a computer system and a software is there whichever shade you want, they just put the coordinates and the desired colors will come out. So that software is also based on the RGB pattern. All the paint companies use software based on RGB. In the software, when we enter the coordinates, we get the desired color. The color in the shade cards of the paint companies are just linear combination of three colors: red, blue, and green. They fix the coordinates to prepare the desired color. Here the coordinates means we have to enter the coefficients of three basic colors, which is just linear combination of red, green, and blue. So there are more other applications of RGB. So in fact, the mobiles you used, wherever there is a screen area, your LCDs, your LEDs, your computers, all use just a concept, basic concept of RGB, right? So whenever you need a pixel, whenever you use a camera, anything that is completely based on this basic concept of RGB. So there, if our scientists and mathematicians were not able to find the concept of this linear algebra, we will not be able to use such pictures and all. So very important part. And so let us move to the next application. I will discuss all the applications one by one. So let us move to some musical compositions. So again, musical composition, you can also view them as a linear combination and basis. So see how. As we know, all the compositions of music songs and melodies are just the linear combination of musical notes. The sargam, you can imagine, because you all the students and even all people used to listen the songs and all, and you already know about the sargam, sare gama pa, we already use so many times. So these all the songs and all they are just the linear combination of musical notes, these musical notes, sare gama pa. So we can take sare gama pa dha ni as a basis set. The set defined above produces all the musical compositions. So it is only depend on this are independent vectors. Sare gama pa dha ni, right? So sa is repeated again. So now how it works, let us see. Many research papers has been published in which it is explained that with the help of linear algebra, how we can make compositions which will always sound good to us. Now, can you imagine, with the help of linear algebra, we can compose good songs. So it is a very good thing. So how we can use mathematics in compositions of songs also. So that means mathematically we can compose such songs which will always be a big hit. So one of this research paper is attached link this way. I have taken this research paper from MIT, the Massachusetts Institutes of Technology, America, and I have put this link here so that you can just view and see how it works. So it is a big paper of, I think, 4 to 5 pages, 5 to 6 pages. So you can read this paper and you will have a good idea. So how it works, right? So let us move to the next application. Very important application of linear transformation in image editing software. Now, machines only understand the language of logics. The applications used to scaling, rotation, cropping the image is done by using fundamental technique of linear algebra only. So in fact, we have discussed the linear transformation and its geometry in detail. You can also, in fact, I don't know whether you linked that geometry in detail in your presentation. So if you have then red, green, blue. So the multiplication of these three matrices will give me a resulting picture. Now, can you understand? If you understand, then please write yes. Otherwise, I will repeat. It is very important to understand. Yes. Okay.
Yes, sir. They're writing.
Okay. Thank you. So you see, every image, the first matrix is related to red, second is green, and third is blue. So the resulting matrix, the resulting picture will be just a matrix multiplication of these three matrices. Now, can you tell me what will be the order of the matrix? Yes, if anybody knows, please answer. Yes or no? If you know, then you can answer. What will be the order of this matrix?
So 3 into 3.
Who is this?
Kavita.
Kavita, no. Kavita, it will not be a 3 cross 3 matrix. Yes, Jyoti. Yes, Jyoti.
5 cross 10.
5 cross 10. Why it is 5 cross 10?
No, you have mentioned 5 5 rows and 10 columns.
So, what is 5 here? I have already discussed a few things. What this 5 represent? These 5 squares. I've talked about something, a term pixel. So this is a pixel. This one square is a pixel. 1 pixel. The color will not change for this pixel yet. It will have one color. The next pixel will have another color, right? So whenever I reduce the size of this pixel, I will get the exact image, right? So sometimes you find a blurred image. That means that pixel are less. If I take a small box here, I will get the exact color of that picture. I hope you understand the concept. So the order will depend on the pixels of this picture. So here, if I have taken 5 pixels along this 5 rows and 10 columns, right? So my square is very large. So for one picture, I have taken this 5 into 10, 50 pixels. So the order will be 5 cross 10. So this is the, so if I am saying here the first row is the red, this red matrix, and the first element of red matrix is 0. That means there is no red color in this. So you can see there is a dark green color. So if I write here 1, 0, and first row in blue matrix as 0, that means only green color will be there. So this is the way how it works. So these are the matrix, 3 matrix. If I multiply all those matrices, then I will get the desired image. So I hope the idea is clear now. What is this? How it works? So let us move ahead. So in order to process image, we multiply the resulting RGB matrix to get with a matrix to get a processed image. Now see, here is the original RGB matrix. After multiplication, I will get a matrix, and I will multiply this matrix with some other matrix, and I will get a desired result. Now, what is this matrix? This is the editing of this matrix, editing of the original matrix. Now, what we want to do? Now, see what happens. Now, if I want to rotate this matrix, I will just multiply RGB with this matrix, cos theta minus sin theta 0, because this is nothing but a rotation, as we have already discussed. So in 3 cross 3, I will take z-axis as 1, cos theta sin theta, because I want to rotate a 2-dimensional picture. So I have taken this cos theta minus sine theta, cos theta. It is just a rotation, as you have already discussed. So when I will replace this matrix by rotation, then this picture will be rotated by an angle theta. So if I fix it by using theta equals to 90 degree, so then the matrix will be 0, -1, 1, 0, and the rest are same. So if I replace this matrix by this, then this image will be rotated to a 90 degree angle. So if you have any doubt, then you can ask. Otherwise, you can write yes if you understand the concept. So again,
Yeah, hello, sir.
yes, Arup.
Uh, so we are taking the image to be in 2D image. So that's why they are the 0 0 in the third row
Yes,
and 0 0 1.
yes.
Okay.
So I will get a 3x3 matrix when I put RGB in one form. So I will have to multiply it by 3x3 matrix. So that is why I have taken it other column as 0 0 0.
Okay, sir.
So next is translation. So what is translation? It is just by taking one image to other place. So I will use this matrix for translation. So it will move x coordinate to x plus a, y coordinate to y plus b, and z coordinate as it is. Right? So this is the translation matrix: 1 0 a, 0 1 b, 0 0 1. So next is flip. If you want to rotate a matrix with respect to one lines, whether it can be x-axis or it can be y-axis. So if it is with respect to y-axis, then it is a vertical flip, and if it is the flip is with respect to the horizontal axis, then it will be a rotation about x-axis. So these are the vectors: 1 0 0, 0 -1 h, 0 0 1. So h is with respect to y-axis, and w is with respect to x-axis. H and R are also the width and height of the image. Okay. So this is the flip matrix, and again a scaling matrix. If alpha and beta are the scale factors along x-axis and y, you want to cut the image, so you will multiply the image by these vectors. Scaling means you want to enlarge or you want to make it small. So these are the metrics that we use in image editing, right? So this is how we edit the image when you do this on your mobiles. These are the ways. This is a basic concept that the software used to edit the image. So next application is application of linear transformation in cryptography. So let us first discuss what is this cryptography. So study of encoding and decoding secret messages is called cryptography, right? So it is used for these days. So many social media application uses this just to make just for security purpose, for privacy, for making the privacy of users, and they use end-to-end encryption. So that is used by WhatsApp, Facebook, and other Telegram and other social media applications. And it is also used by military and government to facilitate secret messages. So the heavy linear algebra is used in cryptography. Now how it works, let us see. So again, I will use a particular example to discuss it, discuss the working of this cryptography. So here I have written some idea how it works. So first, a matrix multiplication is used as a cipher to encrypt a message. Now to make it secret, we write a message in a matrix form, and that matrix is multiplied by some cipher matrix, and it becomes coded, right? So we hide the message by using the multiplication, and that cipher matrix should be invertible, otherwise we cannot decode it, right? So we will multiply the inverse of that matrix so that we can get the original message in a matrix form. So the matrix must be invertible for use in encryption and decryption. The cipher matrix can be as simple as 3 cross 3 matrix composed of a random integer. So cipher matrix can any matrix. We can take any matrix which is invertible. So that for one particular software, it is just a simple matrix of 3 cross 3 matrix, or any. If we want to take a 3 cross 3 matrix, then it will take one form. If there is another matrix, then we can use accordingly as our message, how much length of our message is. So in order to encrypt the plain text, each character in the plain text must be denoted with a numerical value and placed into a matrix. These numbers can range in value. For example, but an example is using from 1 to 26 to represent A to Z and 27 to represent space, right? If you want to make put space, then the number will be 27, and if you want to use any of these letters, then numbers will be 1 to 26, right? So we can also use numbers for other keys also, like 1 2 3 4. We can use one number. For other, like at the rate, capital letters, we can use, that numbers can be increased. So this matrix is then multiplied with cipher matrix to form a new matrix containing the cipher text message. See, here is the example. I have taken a random matrix -3 -3 -4 0 1 1 4 3 4. I have taken this matrix just because it is invertible. So I can take any invertible matrix. So for this example, we will use the following plain text. I have taken this message: penguins are 1 to 1. It's just a random message. Now we will replace each letter with its numerical representation using 1 to 26 for A to Z. Means if I am saying P, the number is 16. E number is 5. G number is 14. U 7, I 21, and so on, right? So I have denoted this number with respect to the number of letters. So if I put space, then I will put it 27. So after 3 letters, there is 27. So after 3 letters, again there is 27. So 27 represents the space between two words, right? So now these are the numbers. Do not go whether I have taken it correctly or not. I have just take it quickly, so if there can be a mistake in taking these numbers. So the idea should be clear, right? So I have taken one number with respect to one letter. So I will put these numbers in form of matrix. See how. So this is the matrix, 3 cross 3 matrix. Sorry, 3 cross 1 2 3 4 5 6 7 8. 3 cross 8. So multiply the plain text matrix with the cipher matrix to form encrypted matrix. So I will take here a 3 cross 3 matrix and multiply this 3 cross 3 by this 3 cross 8, and I will get a resulting 3 cross 8 matrix, right? So this is our resulting matrix. Now it is an encrypted data. No one can understand what is this if it didn't know this cipher matrix. But if anyone knows the cipher matrix, then they can decode it. So this cipher matrix has the important role to play here. So I have encrypted this data. Now you cannot decode it until you know about the cipher matrix. So again, I will multiply this data this matrix with the invertible of that cipher matrix. So this is the invertible matrix of cipher matrix, and I will again get a same matrix. So that will be read by our software as whatever its value, whatever the message was. So penguins. Now you can read it on a vertical way. PENGUIN. Penguin. Penguins. Space R space 1 space 2 space 1 last में space. So if you have any doubt till now, you can ask. I'm just giving you a few minutes to understand, to digest, and after that I will take another example, another application.
Apart from this, if somebody has some doubt, you can also ask. Most of them are writing yes.
If you have any doubt, you can ask, please.
Yes. If you will write yes, we will not understand. What do you mean?
Are you finding it interesting, or it's an application part, and application part is always very, I hope.
I think most of them are clear. Jyoti raised one question: what is the meaning of cipher? I think that is the one thing that allows you to make it some secret message.
Yes, cipher is to decode things.
Yes, that's correct. Jyoti, did you get this idea, beta? Did you understand? I think as soon as sir explained, you might have got it.
Yes, sir. But sir, I have a question now.
Okay.
Yes, yes.
Is there any way so that we can decode it?
Yes, we have already did this. We did here using cipher matrix, and we decoded by using the invertible matrix.
Sir, but how
Sir, I think
one can know
she's
about
asking for that cipher. That if somebody has generated some code, then how we can think about that cipher that allows us to.
That is a permutation combination. You can only
Yes.
take a permutation combination.
Yes.
There are so many numbers. So we have 9 numbers and 9 places. So you can apply
That's correct.
permutation combination.
But sir,
So
if
this
the
is something
message
that we
is
have
too
to think
long,
about.
So what we can do?
That is why it is a security purpose. We use it as a security. Nobody can decode it easily. So
People are using, I think, for this cryptography purpose, people are using some concept of number theory. And then they are coming out with some of the codes, some of the programming part with the help of which they can think about these kind of solutions.
Yes.
Sir, I think you can continue now.
Okay, sir. Thank you.
हम वो सर लेटेस्ट को हम वर्टिकली प्लेस किया ना सर हॉरिजॉन्टली प्लेस किया भी तो होगा ना PENGUI वो सब वर्टिकली प्लेस किया ना
Here also we have written this in vertical form. So whichever form you are writing, you will get in that form only.
जब हम उसका इनवर्स हम मल्टीप्लाई करें तो हम हमें उससे वैसे वर्टिकली ही मिलेंगे
So see, 16, 5, 14, 16, 5, 14. You will get the same matrix. Yes. If you write it in horizontal form, then you will get it in horizontal form only.
Yes.
Okay. So let us move to next application. I have shortened this application because there is some core ideas of computer softwares. So I have not touched that part. However, I will try to explain you because I am taking you as a layman. So I will try to explain it as much as possible in a simple language. The idea was not very simple. I have put lots of effort to make it simple. So, but if you have cleared, then it is a good thing. So magic behind Google's success. Which search engine, the first search engine that comes to our mind is Google. Now, see how Google have done this thing. Now, when Google went online in 1990s, one thing that set it apart from other search engines was its search result listings, which always delivered good stuff. No? So Google is the best search engine till date, and they are using the linear algebra in its very basic way. However, they are using so many rigorous linear algebra in their softwares. So they have started it from 1990, and they have gone through they are using it from 1990s, and now it's 2020. So they have built so much advancement in their Google search engines, and all these advancement is just due to their good understanding of linear algebra. So let us see how it works. Search engines like Google have to do three basic things. First, look the web and locate all web pages with public access. So this is the first. Whenever you write something, they shows you the number of websites related to that words. So now see, second thing is indexing of search the data. So what is the numbering? When you put some words, what should be the numbering of that websites? And third is rate the importance of each page. So the most important part is this. First, they have read what you have written. Second, they put the indexed website on your page. And third, that which website should come first. So this is the very important part. So when you put any search in your Google search engine, so the most important part, that what you are looking, that should come first. So that is the main success of the Google search engine. They put the most important pages first. Now see, big part of the magic behind Google's success. So now what is this? How they rate it? So they use page rank algorithm. So this page rank algorithm involves lot of linear algebra. You see, let us see how. So the page rank algorithm developed by Google's founder Larry Page and Sergey Brin when they were graduate students at Stanford University. PageRank is a link analysis algorithm that ranks the relative importance of all web pages within a network. So there are three features for determining the page rank. First is outgoing links, the number of links found in a page. The links means whenever you type a word, he linked that word with the pages. So outgoing links. So incoming links, the number of times other pages have cited this page. So this means that how many people have cited, particularly clicked that page, and the rank, this value representing the page relative importance in the network. So this ranks the page, and according to this ranking, the order of the website pages are determined. So using techniques of linear algebra, one can compute a unique solution for page rank problem. It gives importance of all web pages in terms of page rank eigenvectors corresponding to each web page, right? So it gives some eigenvector that this page rank in terms of eigenvector corresponding to each web page. So no other successful technique other than linear algebra is available to solve this problem. So, however, I did not discuss how it works because it was quite difficult to make you understand about this concept. So, however, when I will put this PDF of this PPT, I will include those part. If you can understand, then you can You can also ask me. I will discuss with you. So just to avoid the heavy doses, so I have removed those pages. So there are many more concepts that we can discuss, that which is used as an application part of linear algebra. So these are the topics here: electrical circuits, we use linear algebra; traffic flow, genetics, graph theory, quantum theory, economic models, in Leontief economic model. I don't know what is it. Data science, yes, data science is a very important field in these days. So there is a heavy use of linear algebra in data science. And last but not least, that is artificial intelligence. So because a lot of data is involved, so we use linear algebra to handle this data, to regenerate. So there are transformations, so how it delivers, how it evaluate that data, and what output comes, that only depends on the transformation. That should be a one-to-one, linear function should be involved there, so that it cannot intermix. So for that output, the linear transformation is used. So artificial intelligence is also one of the application of linear algebra. So you see, there are so many, and so many others are also I have not specify here. So there are so many applications of linear algebra, so which you can explore. You can explore by yourself how we use linear algebra in this way. If you understand the concept, the basic concept of linear algebra, then you can also understand how this linear algebra is used in these topics. So that is all from my side. If you have any question, any doubt, then you can ask.
Thank you very much, Gaurav sir, for this very wonderful session. I think because sir was able to touch only few things during this lecture, but it gave us a very clear idea about all the applications that where linear algebra is used. No doubt there are so many areas also, other areas also, but this is something sir has quoted all those things like Google search engine, like whatever we are using in Paint, okay, whatever we are using in the Photoshop, all those things have been very beautifully covered by sir. These are few things that we use on our daily basis. So we should know that behind those things, behind those very useful things, the basic underlying concept is linear algebra that we are doing, that we are studying. Okay, so being a mathematician, this is the best thing that we know, that the core subjects or the abstract subjects have a lot of applications. Okay, the initially also I mentioned it, that this is a kind of thing that happens in our case, that being mathematicians, we know the subject, but if sometimes somebody is asking us about the application, we do not know that. So this was, I think, most needed lecture of the hour, that gave us idea about this particular thing, that lot of ideas are there that can be, that we are used to have applications in different areas. So thank you very much, Gaurav sir. We are grateful to you that you spared your time, and you have to make this PPT also. You have to work very hard to bring these concepts in front of the students. Thank you so much.
Thank you so much, sir. Thank you so much for giving this opportunity. It was really very wonderful for me. It was a great experience. Thank you, sir.
Thank you, sir. Students, if anybody has any doubt before we proceed towards the valedictory session, so we have around 5 to 7 minutes for the discussion. So you can ask if you have any doubts. Sir is here. You can unmute your mic, or you can write in the chat box also.
So we can also take pictures if students are ready for that.
We can allow ask them, sir. Yes, yes, yes. Students, can you start your videos? Gaurav sir, are you able to see it? Yeah, that's correct. Students, please start your video.
4-5 students have switched on their videos only. So I
Students,
request
please switch on your videos so that we can click it. If possible for you, please click it. Because on it in the Google Classroom. So if it's possible, you can start your video. I request all faculty from our department to kindly start your videos. All students, please start your video. Rohit sir, please start. Sunil sir, please start your video. Darpan sir, if possible, please start your video. Jyoti, Kavita, Samriti, Ramneet, Shubham, Taranjeet, Bhavna, Ranju, Sushil Sharma, Jashneet, Yatesh, Kavita, Samriti, Ramneet. Gaurav sir, you can take a click, no problem. Students, please smile.
yes. I was going to say that. I was about to say, please smile.
Principal sir has also joined. Welcome, sir. Students, please start your video. We want to take a group photograph. Please start your video. Gaurav sir, is it done?
Yes, sir, it is done. Thank you.
Okay, okay.
So, dear students, our principal sir has joined. So, Gaurav sir, am I audible?
Yes, sir, you are audible.
Okay, okay, okay. So, our very respected principal sir, Dr. Jasveer Singh ji, Head of Department, Professor Parthi Kapoor ma'am, Professor Darpan Sood, coordinator of this program, all the eminent speakers, Dr. Satyendrayana Reddy sir from Shivnadar University, Greater Noida, Dr. Sunil Kumar Sharma sir, Government College Hamirpur, Dr. Rohit Gandhi sir, Government College Ray Kangra, and Professor Gaurav Sharma sir, Government PG College Una, all department members and dear students, a very warm welcome to the valedictory session of this online student development program on linear algebra and its applications. We feel honored that all of our eminent speakers are present here, and I'm very thankful to our principal sir for his vision that this kind of program is the need of the time, and we have to organize such programs. Then I discussed it with my colleagues, and we discussed with the resource persons, and then we come up with the idea of organizing this program. So before we proceed towards the valedictory, first of all, I want to call a few students for a quick feedback on the program so that we can know that what are the things where we are good and what are the things where we have to improve. So in this regard, first of all, I want to call Jyoti from Government College Hamirpur.
So, good evening to all of you. I'm glad that I got this opportunity to attend OSDP Online Student Development Program on linear algebra and its applications. And if I talk about my feedback, then it was really good. As it was well said on the very first day of this program, think geometrically and solve algebraically. So usually when we do linear algebra in our usual classrooms, so we do a lot of algebra, but here we discuss them geometrically also. And as we moved forward, then we saw many things, like we could visualize those geometries in our mind. And in the last, magic happened, like we were doing linear algebra, like we were calculating eigenvectors and eigenvalues, and we were doing them geometrically also. And we don't need to do so much algebra there. So I am highly benefited through this program. And today, as we did applications of linear algebra in a very interesting way, so I would like to say the efforts made by all the resource persons were really appreciable. And as all the lectures are live streamed on YouTube, then we can watch them later also. So thanks to the whole team, and I'm very happy that I was also a part of this program. So thank you so much.
Thank you so much, Jyoti. The next student is Laddi Pavan Kumar, Central University, Odisha.
Hi, sir. Hello, sir. Hello, all of you. Good afternoon to all. First of all, I want to thank SGTV Khalsa College, which organized this awesome program. And then I want to thank all the faculty members, Sangeet sir, Satyanarayan sir, Gaurav sir, Sunil sir, Rohit sir, who have give their effort and time to teach us something, which helped us more. And I can say that I have a great experience here. And talking about the feedback, all were awesome. The classes were awesome, and faculty were teaching us so nicely. And मतलब जब भी हम डाउट्स दोबारा दोबारा पूछते थे, तब भी मतलब कुछ गुस्सा नहीं करके मतलब बहुत अच्छे से बताए हमें, वो बहुत क्लियरली बताए। इसके लिए मैं सबको थैंकफुल हूँ। एंड फीडबैक मेरा एक सजेशन है कि हम जब भी मतलब गूगल क्लासरूम पे करते थे, मतलब असाइनमेंट्स देते थे, थोड़ा और मतलब थोड़ा ज़्यादा असाइनमेंट देने से हम थोड़ा ज़्यादा वर्क करेंगे उस एग्जाम्पल्स पे, तो वो ही अच्छा होता। और सब बहुत अच्छा था सर। संगीत सर, थैंक यू टू admit me in this program, sir. Thank you, sir.
Thank you so much, Pavan. We will definitely look into your suggestion and we will try to include it in the forthcoming programs. Thank you. Next student is Arup Datta, Tirupura University.
Hello, am I audible, sir?
Yes, yes, yes.
Okay. Respected dignitaries and all the faculty members, very good evening to all of you. Myself, Gaurav Datta. So first of all, I would like to thank you all for giving me an opportunity to participate in this program. As during this program, I have enjoyed and learned so many things. Moreover, I can find myself more confident now. So basically, this only I want to say that thank you for giving me opportunity.
Thank you, Arup. The next student is Khushbu from SA Jain PG College, Ambala. Khushbu, are you there?
Yes, sir.
Khushbu.
Good. Hello, all of you. Firstly, I want to say thank you for giving me an opportunity. मेरे को मतलब कि ऐसे था कि मतलब जैसे हम सारे घर में बैठे हैं और एडमिशन्स वगैरह भी नहीं हो रही हैं, तो ये सब हमारे लिए भी था भी, मतलब हम सब कुछ मतलब कि कुछ तो करें घर बैठ के। तो ये एक सेशन था, मतलब हम कुछ कर सकते थे, मतलब कि असाइनमेंट्स वगैरह, होमवर्क, फिर दोबारा दोबारा क्लास देखना अच्छा था। और दूसरी बात ये, जैसे हम मतलब कि कुछ मिस हो जाता था मेरा नेटवर्क इशू की वजह से, तो हम यूट्यूब पे स्ट्रीमिंग से भी देख सकते थे। तो थैंक यू, और ये सारा कुछ एप्रिशिएबल था। थैंक यू।
Thank you so much, Khushbu. Samriti from Government PG College, Una.
Good evening, sir. First, I'm very glad to have this program, sir. ये बहुत यूजफुल रहा, जैसे इतना इंटरेक्शन नहीं हो पाता था टीचर से, कॉलेज नहीं जाते हम, और इससे हमें बहुत कुछ पता चल रहा है। सिस्टमेटिकली हमें बहुत कुछ पता चल रहा है। क्लास में तो हम अल्जेब्रिकली सॉल्व करते थे, अभी हमें ज्योमेट्रिकली भी पता चला और ज़्यादा क्लियर हुए कंसेप्ट। जैसे हम बार बार डॉट्स पूछते थे तो आप भी अच्छे से बताते थे। दैट्स इट, सर। थैंक यू सो मच।
Thank you, Samriti. Utkarsh Rajak, St. Aloysius College, Jabalpur.
Yes, sir. A very great good evening to all of you. First of all, I am very thankful to the respected principal sir of SGTB College, respected Dr. Sangeet sir, respected all the resource person, and to all the organizing committee. As per my point of view, I really enjoyed these past 10, 12 days of online session. I thought it was very well planned and laid out, easy for me to follow all these things. I really want to appreciate and so grateful to all the resource person, the way of interacting with us, way of teaching. Once again, thanks a million. Thank you, sir. Okay.
Thank you. Manisha also want to give feedback. Manisha, you can unmute.
A very good evening to all the teachers. Myself, Manisha, and I am from Maharana Pratap Government College, Amp. First of all, I want to thank all the teachers who gave me this opportunity to participate in this online development program. This is a great course. I enjoyed all the sessions. I really want to appreciate and thank all the speakers who gave us such an excellent knowledge. The way of teaching and explaining everything was outstanding. Discussion sessions were also very good. I thank all the teachers for very informative evening. Thank you, sir.
Thank you very much, Manisha. If any other student also want to give some feedback, you are free. You can give your name, we can call you. Okay. So thank you so much, students, for your this inspiring feedback. It will also boost our morale that we can do more better in the coming programs also, and we will try to organize few more programs. And as you all mentioned that I want to mention this thing because initially we have not planned to go for the YouTube live streaming. As soon as I discussed this idea with our principal sir at the same time said, why we are not going for YouTube live streaming? You should make that arrangement because it will be very helpful for all the students because there is a limit in the Google Meet. And now in your feedback also, as students have given feedback and you have written it clearly that after the session, if you had some doubt, sometimes you were disconnected due to the network connectivity. So you were able to see all the videos. So this all thanks goes to the vision of our principal sir, who has this idea that if we go for the YouTube live streaming, it will definitely help all the participants, and it actually helped you all. So thank you very much, sir, for this idea, and because you have also listened that students are again and again appreciating this particular thing. And one more thing that I want to mention about the YouTube live streaming, a special mention for the two people from our department, Aditi and Jasprit Kaur. They are faculty members of our department. They took full responsibility of this YouTube live streaming. They worked hard. They have to learn all the things, and they managed it all. And they tried to start the live streaming on time. And in case there was some problem, they were always there to take care of it. So I'm grateful to those two people also, because it made a special mention. So I wanted to mention them. Now I request our principal sir to give his blessings to all of us. Sir, please. Sir, please, your mic is not on, sir.
Thank you, Dr. Sangeet Kumarji. Thank you very much. Respected Dr. Maninderjeet Kaur, Vice Principal of the college, Dr. Satya Narayana Reddy, Shiv Nadar University, Greater Noida, Dr. Sunil Kumar Sharma from Government College, Hamirpur, Dr. Rohit Gandhi from Government College, Ray, Kangra, Professor Gaurav Sharma from Government College, Una, Professor Bharti Kapoor, Head of the Mathematics Department, Dr. Sangeet Kumar, Convener of the program, Professor Darshan Sood, Coordinator of the program, Dr. Vimal Mehta, Coordinator, Deputy Star College Scheme, all the teachers and dear students. Vaheguru Ji Ka Khalsa, Vaheguru Ji Ki Fateh. First of all, I want to welcome you all in the valedictory function of online student development program. You all were present in the program for 14 days. I hope you have learned new things and enjoyed this program. I want to congratulate Mathematics Department, Professor Bharti Kapoor, Head of the Mathematics Department, Dr. Sangeet Kumar, Convener of the program. I want to especially praise Dr. Sangeet Kumar. Dear students, you can see the important role Dr. Sangeet Kumar played in this program. I want to tell you all that Dr. Sangeet Kumar is a very important person in our college. Please clap for Dr. Sangeet. I want to thank all the persons. As you have seen that all the time your teachers were with you, and I hope you have learned many things, and this program will be for years in your memory. Mathematics department of Shri Guru Tegh Bahadur Khalsa College Anandpur Sahib is doing a wonderful job, and our teachers work as team, as you have seen in this program. At last but not the least, I want to congratulate all the teachers, students, and want to thanks to all the participants. Thank you very much.
Thank you very much, sir, for your blessings and appreciation, sir. Now I request our department head, Professor Bharti Kapoor ma'am, to say a few words and thank principal, sir.
Thank you, sir. Good evening, everyone. It's been very engaging and fascinating 12 days. And the purpose of student development program was to give knowledge to the students about basic concepts of mathematics and give insight about few application. And I'm very thankful to our resource team who beautifully served the purpose. I extend my sincere thanks to Dr. Satyanarayan Reddy, Dr. Sunil Kumar, Dr. Rohit Gandhi, Professor Gaurav Sharma, Dr. Sangeet Kumar, and entire mathematics department. And I also congratulate them for their commendable effort. And my heartfelt thanks to Principal Sir, who always supported us and encouraged us for organizing such events. I'm really thankful to you, sir. And I have been very impressed by the ability of the participants who were interacting throughout and were able to answer questions put out for them. I hope this student development program will enhance the knowledge, thinking, and understanding of the participants about higher mathematics, and they will take away new learnings with them. Thank you, everyone. Have a wonderful evening. Thank you.
Thank you so much, ma'am. So thanks everyone for joining. Now, if anybody want to say something, so because we are going to close, this is something that I say at the end of each program, because whenever we are doing some program, we know that we always get very busy. But whenever some program comes to at an end, whenever I'm organizing something, I'm always feeling the same thing. That whenever it comes to an end, I always feel that what I will do from tomorrow onwards. So this always happens. So I hope this might be the feeling with students as well as other teachers also, that but as students have said, we are soon going to think about few more programs based on your feedback. So now I request the resource persons if they want to say something to students. Satya sir?
Yeah.
Please, sir.
Nothing as such. Okay. Yeah, all said. Yeah, it is very nice to see all of you for the almost 12 days. In spite of your other coursework and other things you participated, 12 days is not a joke. Almost for 2 hours. It's wonderful to be here. And I'm suggesting Sangeet Kumar and other resource persons that it may be better to continue that Google Classroom for some more time.
Okay, sir.
Yeah, so that they may ask some questions. So let them, they among themselves may discuss. We do not know. So we at least give 1 month time, and then afterwards we can close that Google Classroom. That is just my suggestion. That is one suggestion. Yeah, and yeah, it is good. And also, participants can ask the resource persons to float some, for example, one Google form they created on exam they conducted. Like that, if you want to take more exams, then you can ask Sangeet sir. They say they may put one more exam based on entire thing. Yeah, so that it will go into live. But main thing is I want to say is that do not stop here. So go back and again, you people make up from WhatsApp group or something and start discussing. So please continue this. Do not stop like that. You yourself make up knowledge grows, right? Yeah, that is what I want to say. Yeah, best of luck to for your future endeavors.
Thank you so much, sir.
I'm thankful to organizing committee for making make me part of this program. I'm very thankful to all of you. Yeah.
Thank you so much, sir. Sir, we are already conducting one more quiz for the students, and that may be shared maybe by today evening. So we are conducting that, and we will keep this in mind, and we will keep this Google Classroom working for students at least for 1 month. Yes, sir. Okay, thank you so much, sir. So thank you so much, students. Now you can leave. So we are now officially signing off for this particular program. So hope to see you soon in the coming programs. Okay, and there was one instruction that I made in the beginning regarding one lecture on inner product spaces. We will update you regarding that on what day in the coming week we are going to conduct that. Thank you so much. Thanks for joining. Thanks all resource persons and principal sir. Thank you very much for your all support and blessings. Thanks my department members. Thank you very much.